Welcome back to the channel. Today we are solving round 951 C earning on bets. You have been offered to play a betting game. There are n possible outcomes. For each of the games you need to bet a certain integer amount of coins and you are given a multiplier for the bet. You will win any one of these bets and you need to determine a distribution of coins that you bet such that if you win any bet you should still not lose any money. Means the amount of coins you bet on all outcomes must be strictly less than the coins received back for every possible winning outcome. Okay, so let's start with the first test case. 3 2 7. Now this means कि if I win the first bet, my money will be multiplied by 3. If I win my second bet, my money will be multiplied by 2. If I win my third bet, my money will be multiplied by 7. Now, uh, uh, an easier approach will be to think कि whenever you should win a bet, no matter which multiplier you get, then you should receive the same amount of coins. That means no matter if you win this bet or you win this bet, you should still get same amount of coins as the multiplier. Because if you go into other possibilities, it will get very difficult to find an answer that satisfies all permutations. Therefore, we will be fixed on this simple observation that no matter which one we win, we should get the same amount of coins. Now, if I want that to happen, first of all, I will need to find the LCM. What is the LCM of 3, 2 and 7? LCM is 42, which means if I win the 3x multiplier, I should bet 14 coins because 14 3s are 42. If I would win by the 2x multiplier, I should bet 21 points. If I should win by the 7x multiplier, I should bet 6 coins. Now, no matter which bet I win, I will always receive 42 coins. And how many maximum coins have I bet? Total 41. So, in all cases where your LCM is strictly greater than the sum of all values you have bet, then this is a suitable permutation. But if the cost of this is greater than or equal to your LCM, then it can be proved that there are no possible permutations which exist. Now, for the example, we'll take a test case. We'll take a test case 632. Now the LCM of this is 6, which means I should bet 1 over here, 2 over here and 3 over here. Sum of this is also 6, which means it is not strictly greater, and so the answer is -1. Now why? Now suppose you try to make an, uh, another combination, like if you put 2 over here, okay, then if you win by this bet, you win 12 coins and you have bet 7 coins. Okay, if you win this bet, you still get 6 coins and you have bet 7 coins. So this is where it goes wrong. Now if you try to increase all of them a bit, like instead of 1 2 3 you go 2 3 4, then if you win this bet, you get 12 points. If you win this bet, you get 9 points. If you win this bet, you have 8 points. And the coins betted are 9. And so 8 is less and 9 is equal. Only 12 is the winning case. So if you do not get a value for the previous case, then no matter what value you try, you will not get any other permutation. This I got to know by applying this logic on some test cases like this 632. I tried putting these values as random as possible and I did not get a successful answer. So here's how the code goes. We take the LCM of all of the numbers. Okay, that is stored in our some variable, and then B stores all the coins which I am betting. B of I stores the coins I am betting on the ith stake. So B of Y is LCM divided by A of I. And then I have to check whether the sum of all of bets, it should be less than my LCM. So if it is greater or equal to, I have no answer. Else this distribution which I have found is the answer. Okay, so thank you guys for watching.